Hey, hey, hey. Start the show, huh? I'm multi-streaming, so I'll take a few more minutes to get my streaming dashboards up and available for me right here. Meanwhile, well, I'm here, of course. I'm just getting all these tiny details available for me to track all the streaming destinations, which are in order of sort here in my tabs: YouTube, Twitch, Kick, Trovo, D5. 1, 2, 3, 4, 5. And since recently I'm keeping usually keep an eye on my stream on Kick. As it has right away re-encoding into lower bitrate and lower resolution. Well, right now I can already jump here before I finish that up. Okay, I'm already ready. I guess the title shows for the stream Day 5 for me, learning Godot. I want to go into scripting, GD script. More about that in a moment. I'll switch here and share my overview. Okay, I know now that the audio is okay. I can mute my monitoring. What I need is this is the, it's not Hyper Arcade anymore, it's the learning. Where is learning here now? I need to put here, do I have here group in OBS for learning? No. Loading, learning. No. Cancel GDI text. Learning. Okay, here it is. I'll leave it large for now. Can I arrange these? Capture window, capture viewports, widgets. This will be the full screen main. And this is just for now the streaming dashboard. I'm sharing it here. So, and lastly, I need to grab, well, since I've got it all, I'll paste here in the chats. What's going on? So I've got the kick, I've got these I don't have, YouTube and that. Okay, so YouTube live, hit F5, refresh, pop out quick actions, Twitch, pop out activity feed Twitch, and pop out chats Twitch. I don't use the service to relay the chats because it's not compatible with all streaming platforms, and I don't want to give them all the data. I don't mind doing it this way, and it's good to take this approach from my perspective for the start of the stream. Instead of starting soon, it's already started and it's happening. Let's warm up. And YouTube. Yeah, this monitoring all my computers are. If I put them all together, I will get one decent computer. But each of them can do a dedicated task well, like monitor streams and do the capture and streaming, dedicated i5, monitoring on the Intel i3, and development gaming on Switch console or AMD Ryzen with AMD GPU RX 590. Again, all the machines. They're all old. Activity feed, chat settings. Okay, Day5, cool. I didn't notice any activity here with us on Day5, and that is suggesting me to push Day5 on a back burner probably sometime soon and try another platform. In this message pinned. Please pin this message. Yep, yeah, yes, pin. No message pinning on the live. Maybe I'll try Billy, I don't know. I've got some followers on Kick. My YouTube is a bit growing. Of course, I'm not hype and popular. I could say that's not the way I roll here, but who cares? Who cares about me? But I said to myself, if I'm gonna do this ever again, learn something new or do development or something creative, I'll do it live. What a wonderful world. And I told myself, I'll do it live and make videos. And going live is actually doing myself a service, cutting down the production time. Video is already uploaded. Hey, I just need to slice it, dice it. Did I got this all sorted? Let me see. Throw, chat, dashboard, delay, activity, chat, kick, activity, chat, Twitch, activity, chat, quick actions, YouTube. Let's go. Music feels a little bit hotish. Can I chill it down a little bit? I was saying I'll do this, but raise the compressor. Well, that I didn't cool down the music. Actually, I'm making it even warmer. I got it to react quite soon, but I squished quite a lot with sidechain ducking. And maybe the, well, yeah, and again, intro. Dude's the intro. Let's see. And one more thing. Where's my fancy interactive background? Yeah, like that. Something happening in the background. Hello and welcome, ladies and gentlemen. This is live recording and rehearsal session from Studio Lab at Edoga, which is myself, who is myself. And working titles, production, growing cancer, or league for cancer. I'll explain that some other time, but my second name is Crab or Cancer, so there should be a league for me, not against me. That's the thing. Of course, I'm Eddy, I'm your host, and you're watching Eddy does Internet of Capitalism, or restricted gaming, in a sense of giving an advantage to creativity, but trying to get some good feels, good vibes from it, about learning, grinding. So gaming for sake of learning, edutainment and edutaining ourselves. Working title, gift knowledge, gift that keeps on giving. And just to point out, before I cut this long stream recording into shorter bites, shorter episodes, you can check the end of the stream recording and see the recapitulation that usually I do there. And over there will be in a dedicated video cut from this long stream in recapitulation. There will be a link to my website where I'll publish those shorter bites, more useful bites, more elaborate. And that was the intro. What you think? Eh? Let's go. Do I go full screen? No. Few more minutes to warm up. No more. Few moments. I'll be here. I just do one more thing in the background to prepare. the materials, learning materials, yeah? Nice, and here we go. Little bit of uptime during downtime. No reason. Because already we got here this super thing. There we go. Okay. And here I have the official Godot documentation. I was looking for a link to the learning GD script in the web browser app. I'll go through that. Hopefully all the way through. And then I'll go into the here in the official documentation, not best practices but in getting started section, step by step scripting, creating first script. That this is good entry point for this subject. But first, of course, the learning course app. I visited their webpage sometime before, and I noticed it freezes if I leave it for hours. Here it's loading. Can I continue? Oh, there are some settings and options here. Text size maybe larger, huh? Sample text, cool. Scroll sensitivity, camera frame rate, lower contrast. Apply, close. That's good, that's better. Clearing my throat. Telling computer what to do. I'm not going to go through all this. This looks to me like introduction. I think I went through this. And I want to go into more meatier stuff. But there is already a quiz. How do you give instructions to a computer? Well, I guess this is the... Then... Potato. You'll learn to code with GDScript. In this course you'll learn the GDScript programming language. The name stands for Godot script. This is a language by game developers for game developers. That sounds familiar. That rings a bell. You can use it with the Godot game engine to create games and applications. It's language used by games like Dome Keeper and Rotator engineers at Tesla also. Okay, I've seen this a few days ago. Excellent. Okay, it's excellent. It doesn't have an overwhelming amount of features for you to learn. Most programming languages are similar. Well, I'm not myself doing a tutorial for you, I'm just sharing my learn experience. And the share experience learning. Spotting differences in GDScript and JavaScript. Well, they don't use curly braces for syntax, for code blocks, constructs like functions and scopes. There are no namespaces, but we can also call them namespaces. Python, so most familiarity in the syntax is in the Python. What's the is this the columns to mark the opening like code block for the where the logic is implemented. Nested code block that will execute on the condition or a loop like for each and similar or while, but they're all actually, you can call them conditions. Now I have many similarities. Okay, this course is for beginners. It's a course. Is it a course or course? If I want to learn to make games or code, but don't know where to start this course, okay, I thought we already started. We designed it for absolute beginners, but if you already know other languages, it can be fun. Yeah, that's me. We'll give you the coding foundation to start making games and applications. So we'll actually go through the usual like a definition or definitions and syntax rules of engagement for any programming language, like types, functions, operators, comparators, conditional statements, and so on, loops, branching, and then while logic. Perhaps something like object-oriented abstracts. Member variables, shared, exported, exposed interfaces, the higher logic stuff. I'm just curious one more time about my audio. Well, it depends on the track. Some tracks appear getting squished in volume more, some tend to push their way. Anyway, what and how I'll learn. In this course, I'll be learning the foundations. You need to start coding things like these. Inventory, oh cool, inventory. Is this pathfinding? Gems? Wow, gems. I'm all in for gems. Along the way, they'll teach me some, not all, some of the mindset you need as a developer. I need. Too many programming courses, skip the essential part, how to write GDScript code, essential programming foundations to get you started. As I go through the course, I will have many questions. We'll answer them the best way as we go. Okay. There's so much to cover that we have to take a few shortcuts. We don't want to overwhelm you with information. We also want to respect the pace at which our brains memorize things. We broke down the course into short lessons and we put too much into each part, you'd learn slower. If at any time you're left with burning questions, you're more than welcome to join our... I'll censor that. I'm headed to Discord. Everything is Discord. Isn't there internet anymore? Aren't there free blogging services? You can write articles, leave comments, create forums. Close me in your Discord. Get out of my country. Is this for Godot 4? You learn blah blah 4, you learn 3, okay, 4, same in Godot 4, okay. 3, same as 4, but the fundamentals. Programming is a skill. Each lesson followed by interactive practice. Speaking of which, it's time to look at the practice screen. Try first code next. Run your first bit of code and see the result. Practice, open this practice, okay. Goals. We prepare the code sample for you, and this is cool. This is similar to the first script in the official documentation. For this practice, I don't need to change anything. To test the code, click run button below the code editor. Hints. Hint 1. Click the run button. Run the code. Open practice list. Okay. Output, close, open. Okay, that's how the interface works. So this emulates the editor itself. Editor has also the view screen and the output screen out like a console. So what I've learned this far is that this command will print the welcome message like a hello world. They're trying to be original here than the usual hello world. And if I run this, we get the welcome in the output, but that's not the actually viewport of the, let's say, game. When I program, I'm bound to run into errors, tons of them, but you shouldn't worry. Well, most errors the IntelliSense generates, checking each type character. Errors are a good thing. You will encounter errors and it's okay. Try. Every programmer does, especially professionals. It's cool. Maybe you learn the mistakes are a bad thing. When you code something, it's not the case. Errors help you write correct program because they show you what is wrong in your programs. A code error looks like this. It's a message that tells you some bit of code doesn't work. The function move already exists in this class. At line 20 to making errors friendlier. Error messages can look a bit cryptic. This is because they are designed by programmers for trained programmers. We added an error translator in this sub that will help you get started. It shows you why an error happens and what the message means. It also gives you some tips on how to fix it. The function move already exists. Okay, why this happens? You're already trying to define a function or variable that already exists. You can't do that. Perhaps the function or variable already exists in current code file, but it also may be a parent class that this Godot 6 script extends. So inheritance overrides. How to fix this? In the app, your code extends some built-in Godot code that's not visible to you. In the app, your code extends some built-in Godot code that's not visible to me. When that happens, You need either rename your function or variable to the one that will not collide. Okay. Error messages are designed on purpose by fellow programmers. I should think of errors. I shouldn't think of errors as failures. Ultimately, you want to fix all errors, understanding what's causing. Okay, cool. Are error messages good or bad thing? They're good. They're error messages. Okay, let's see an error in action, please. Practice button, practice. Fix your first error. This code is incorrect and will cause an error when I try to run it. The code defines empty function name, so what's wrong with empty function? Okay, so to close properly the function, it requires a return statement. Returns on functions can be null or void, like nothing. Not every function needs to return a value or a result, or a true or false. Bool, not operator, but bool. Evaluation statement. It's good practice if you ask me, it's good practice to at least return true or false in a function to confirm that it executed properly. It depends. If it's a very complex application being built, then it can help track during runtime, like internal logic debugger, especially for the user journey through the while using on the production side. It's like a intermittent debugging, but while developing the code, a better approach is to use the debugging facilities in the IDE or development environment. Then it's easier to strip faulty code blocks by changing the debugging configuration, actually, that allow including different code blocks, like very complex logic constructs. What I used to do while I was developing a business application, and it took something. I was developing a real-time JavaScript that is asynchronous functions, and there is it's non-linear logic. There is the application was executing in a loop, and I had to handle a lot of data coming into the app in that loop and prevent memory or breaking the app unpredictably, as it's constantly looping and waiting for response, which may happen or not happen on time. And to build that logic and make it stable, I developed few versions of similar code, and so that's why I'm referring about that in this kind of fixing debugging section of this course, because as I was developing my method to exclude logic blocks with comment wrapping large scopes of code and program logic, then I realized, okay, I'm doing myself a disservice. There is also already a debug configuration I can use to actually track my execution. But I like my approach because my logic I was building was kind of non-standard. But then I realized in parallel, actually, okay, this is what debugger should provide for me. So later in production, I can exclude all irrelevant non-production code that doesn't, and program logic that doesn't go into the production, just with selecting production build at the end for the project, and that will exclude all the parts of code source in the source that are not of the production value. So the goal in this lesson is fix the first error. And it says, to work, the function should use the return keyword, but this keyword is currently inside a comment which the computer ignores. And of course, so if I run it, get an error, intended block expected after declaration of this code is wrong function. Sometimes errors are reported outside your code. What does that? Are reported outside of my code. Why does that happen? So if I would do this, remove the hash character and run, it works, but double check. This will also break the code, because this return is outside of proper use case. It should be included with indentation to the scope of function definition and actually inside the body. So it's clear that is a referencing, returning, closing in the source code the function this code is wrong. And that also fixes the error running the code. All checks, hints. Well, this is good because as we learn the language, then it gets simpler to use the learned language as a actual human language. The brain finds a way how to utilize the syntax in our mind, and then you can start typing. You actually just start scripting, writing a script, almost like making a script for a play or a movie, but this one is interactive. Am I done? Next. We stand on the shoulders of giants. I will see if I can go skip this calling functions. Okay. You'll always use a lot of existing code. Well, they said a moment previously that the coding is a skill, but so my suggestion is that even if there's a good source to copy another source code and paste it just in my own source file inside my program up. I would still rather write it down manually than just paste it, because when I'm writing it down I can personalize it, customize it to my use case for the function, code logic, programming logic, program logic, and then it becomes mine. It's better because as we write programs, apps, more we type them in, more we understand the logic, less need for it, and it's easier to debug it when I know what are all the phrases and naming conventions I implemented. Modern programming languages can pretty good accommodate human language, readable human language references in the variables names, methods, functions, and so on. So that's a good, like a meet in between situation when I can read the code almost like a human language. So we are going here into functions. When I tell a computer to execute a function, I call the function. I call a function I write its exact name followed by an open and closed parenthesis. Parenthesis, closed and open parenthesis in the variable name, which actually identifies it as a function or a method. Additionally, parentheses can take parameters into function to execute operations on the provided or passed, the terminology is passed parameters. Once an entity, okay, so show in Godot, calling show. So this is good. This is what I wanted to get familiar with the specific commands, methods, functions in the GD script that can actually trigger events or change properties for the given object in the engine. In Godot, calling show makes something visible like a character. So that's already a direct reference to the viewport in the for a game or an app during runtime. Because showing or hiding an element, it does refer as it has a given name. What is it? A verb, show, hide. It says something will be shown or hidden, but it's still, you know, not super clear. Is it showing, hiding some property somewhere else, or straightforward show and hide in during runtime on the screen? But since this is the game engine or a tool to code for user interface and visual elements, then I can just take it for granted. Once an entity is visible, calling show again doesn't have any effect. Okay. Similarly, once you hide something, calling hide again doesn't change anything. Click run button on any example below to execute the code listing. Run. It's not okay. Reset. In the code listing above, we write a function called hide in a new function named run to execute the code. Creating a new function is necessary to execute instructions in Godot. Can you tell me more about the run function? Okay. In GDScript, unlike in some other languages, we must write our code inside of custom functions. You'll learn that functions are and how I'll learn what functions are and how they work in great deal in the course, but here's a quick look of them if I'm curious. A function is a bundle of code you can execute anytime. It's a named list of instructions. Yep, that's good definition. Named list of instructions. To define a function, I need to write the func keyword func keyword, the function's name, parenthesis, and a colon. Function run, open close parenthesis, colon defines the function name run. You then go to the next line to write the function's body. That's the instructions of the function. Notice how each instruction starts with a leading tab character. The computer uses that to know which lines are part of the function. Throughout the course, you'll see many functions called run. These are functions we created to give you interactive examples. That's a good thing, because there are functions that are like a built in the engine. They have global scope or are inbuilt methods for the built-in classes. Or logical structures, constructs like nodes. But let's go with these function arguments. We use parentheses to call functions because you can give the function arguments inside the parentheses when calling it. Here's a sprite standing straight. If we call the rotate 0.3 function, the character sprite turns by 0.3 radians. Function run rotate. Run the rotate. Okay. And if I run it, I get it turned around. The 0.3 part between the parentheses is the function argument. Arguments are values, numbers, bits of text and more that can change how the function behaves. Arguments let you fine-tune the effect of the function call. They can be optional at times, but functions often require arguments in order to work. For example, calling rotate without any argument would result in an error. Error rotate without an argument or passing the values. Without an argument, Godot doesn't know how much you intend to rotate this sprite. Don't worry about memorizing what arguments each function requires or accepts as a program, and the documentation will always be close by for you to refer to. Finally, notice how we used a dot in the number 0.3 above. You need to use a dot like this to represent decimal numbers. You can't use commas as they are different purpose in code. What are radians? Okay. Primary school. What does this code below do? It makes the intuitive like game character or sprite visible. It calls a function named show. I'll select all that apply. Okay. Another example. With the move local X, you can move the character to its left and right. The function takes one argument, a number of pixels, to offset the entity. The complementary function move local y makes the character move up and down, so x horizontal, y up and down, left right, up down. This is one way to move a character in a game, although we'll see more powerful ways to do this later. This is one way to move character in a game. Run, 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 go away, go, okay, and we got the overflow. And it's a little bit, so it's bound to, it is bound to viewport, that's why it doesn't slide outside. Further, if I reset it, I get here, so it's going diagonally up to this point when it just repeats the same path. Why move local moves the character down? Okay, good question. With positive values 20, the code above moves the robot to the right and down. This is probably different than what you studied at school in math classes. The horizontal axis points to the right, like here, but the vertical axis points up. In video games and generally 2D in computer graphics, the vertical axis points down instead. So whenever you move something on the y-axis with a positive value, it will move down. Okay, so I guess is that because the 0, coordinates are in the top left corner? That's probably standardized in CSS and whatever, everything taking reference to the screen display. How do you call a function? What is the syntax to you use to call a function in general? Closing parentheses. Okay, practices. Make the character visible. Our robot character is invisible. Call the show function to make it appear. So show do I need? Is there return required? Not this time. Can I go back? Documentation method, so it's method. Void show. So show return. This is a documentation statement from documentation description for the method called. This word before the in front of the as a prefix to a function name call refers to usually return value expected for the function. In this case void, as the show function doesn't return anything. And that's all. Practice list. What's this? Practice upright. Okay. Okay, rotate 0.5, I guess. Wow. I'll stay and check here the documentation. So float void, so this method rotate radians again, so this statement here, method description, explains the return value none or void, and it takes radians in a float format. It means actually the memory footprint will be in a format of a float type, data type defined in the technical specs for the given programming language, for the type definitions, and that refers to how many decimal places it takes in this case. I think floats are different than decimals, but take more memory. They can take more memory they can have more, they might have more decimal places. I think that decimal is set to 2, and so on and so on. But hey, let's learn from them. 1 hour in. Drawing a rectangle. We'll use code created by others like we did in the previous lesson. This time we'll solve more complicated problem. Drawing shapes. Oh, this is what I wanted. This is what I wanted. How much is possible to create just from code? We present you the turtle. We created a turtle to teach you how to call functions. The turtle is a little machine that moves around, moves forward, turns, and draws lines along its path. Wow. To make it draw, you give it a list of instructions. On each code line you'll call one specific function. We prepared several functions for you. Move forward, pixels. Turn right, degrees, okay. Turn left, degrees. I'll use these functions the same way you used rotate before. The turtle draws a line as it moves. We'll use this line to draw shapes. For example, to move turtle 200 pixels, right, move forward 200, run. Yeah, I know. Yeah, I know, guys. You boring? Are you bored? Did you have anything better to do? Turning left and right. The function turn left and turn right works the same. To turn 45 degrees to the right, I'd write turn right 45. So, execution sequence, move forward, turn, so move forward 80 from here to here, turn 45, move forward, and it's done turning. Can't turn anymore. How come? Wait, it did turn, so no, this is move forward and it didn't turn or do the rest. Is that because I've changed the font size, making all this larger, so it doesn't have, there is a collision detection, there's a collision detection hitbox around the turtle, so it stops the drawing of the shape as it gets to the bounds of viewport. Anyway, try to understand the example below. This will be some, what's it called? Not square, but not polygon, but rectangle here. Okay, I'm going straight to the quiz. Which part is the argument? It's 30, that's the argument passed to the function. Yeah, I'm right, of course. The turtle uses code made specifically for this app. The turtle is a little learning tool, custom made based blah blah, teach you how to create functions, so please don't be surprised if writing code like turn left inside the Godot, it doesn't work. And don't worry, once you learn the function, okay, cool. Use the turtle to draw a square corner. I previously, on a previous stream, I jumped straight into pre-made Godot projects, demos, templates, but I did have a plan to go into the code step by step, but this is very important, very important part, because it trains to brain to pick up references from the source code and get myself to start speaking, designing in my head and using the verbiage from the code of the programming language given to describe, compile my vision, my project. And these bits are super important, because learning this at first the right way, it will be always clear to read through any even more complex code. So right away they said here that the functions they've created for these demonstrations are specifically designed for this demonstration. They don't work. If I open the Godot and try use this, copy paste this, it will not work without the rest of the code that is behind this especially designed demonstration. This means that actually this function is custom. It's not built in. I think even show and hide they used previously. Drawing a corner. In this practice will tell the turtle to draw a corner. Corner is made up of two lines that are 200 pixels long. The lines are connected at each end by 90 degrees or a right angle. And of course, good color scheme, syntax color scheme is also important in the code editor app. And they have all the science inside behind, and color schemes, color themes for the code editors. I'll stay. method descriptions, pixels. So pixels are integer, meaning like whole numbers, the whole numbers without decimal places, rounded numbers. Same for the degrees in the turn right function, and I'll continue. Drawing a rectangular. Okay, I know right away. This is similar to, let's say, Microsoft Basic in the 80s, like for MSX or ZX Spectrum, ZX Spectrum, that have the drawing functions inbuilt. I'd like also to play a little bit in a video on stream with those 1980s basic functions that support sprites, drawing, sound, like for MSX. MSX had, I think, almost perfect basic implementation. Unlike Commodore 64 that had none of those elaborate graphics functions or sound. Everything's supposed to be done referencing directly registers in the computer. The bare metal. So we could say that Commodore 64 had just two commands for graphics and sound. Peek and poke did it all, and data lines, of course. What's going on here? Move forward 120. Is that it? Then no, don't tab, no indent. Turn right, move forward. I'm just spamming this thing. 90. Is this forward? Turn. Forward. Turn. That's 2 lines, 3, 4 lines. Would you imagine that? Good guess, eh? Drawing a bigger rectangle, write out calls to functions move forward to draw a rectangle with 220, height 260. We wrote the lines first two. We wrote first 2 lines for me, you, me. Every line should start with the tab, one tab character, so the content states part of the. Okay. Well, as a matter of fact, I'll do I'll go cheat mode. Copy, paste. No, paste. Two, 3, 4. So it's expected to go 6, 6, 2, 6, and I guess last turn is not required. Wow, well, short break. Time for a short quick break. 1 hour, 15 minutes in, 13. For the reason of the, like so far, you've noticed I switch always to this thing. but I'll skip this tune. I don't know what's this tune about, but I want some better beats. Heavier beats, I expect. Shout out to Face just popping up in Kick over there. Thanks for that follow. False Face F1A FA1C Fancy Falsy Facey. Anyway, great to have you here. I'm here, but I'm just taking a short breath after talking an hour. How's your day? How's your day over there on Kick? What's the time over there? About midday. Or morning, late morning, midday. Okay, continue with the learning stuff. Yeah, I do here hard things, hard and boring things to be a wealthier person. Doing hard things makes me more valuable. Better growing my capital while learning. Info capital. Okay, done with this. Going back to full screen over here. Footloose. I've lost my foot. Have you seen my legs? And so on. So, finish that section. I'll finish this previous section. Drawing, controlling the turtle to draw. I've called the function existing functions, custom functions. And now I'm supposed to learn, create my own function. Do I really want that? Yeah, I want that. I really want it. And I really need it. So functions are named sequences of instructions. Got it. Using the identifier, we can get the computer to execute all the instructions inside a function as many times as we need. This is what a function call does. Learn more about identifiers. Okay, that's good. So in computer programming, we talk about identifiers rather than names. It's because function name is a label the computer uses to precisely identify and refer to a function or other code elements. Identifiers are unique. You can't reuse the same name in a given space or scope in your code. If I try to name two functions the same, the computer will say, Yo, what you doing? If there is any code that I need to run multiple times, you just put it inside a function and give it a name. Yeah. If there's any code that you need to run multiple times, okay, the instructions inside functions can be any code I want, and they will all run every time you call a function. There can be even a function call inside the function, calling another function. Move and rotate. We've seen that. What's the big deal? Here's the instruction. The instructions inside the function can be any code. Okay, here's an example. Move. The move and rotate function consists of. Okay, move. Oh, is that trick? Move and rotate. Move and turn, meaning rotate. I could write another function that calls move and rotate 4 times to draw square of length. Okay, for move and okay. Oh, is that the thing? Move and rotate, same function, and I get the 1, 2, 3, 4. Every time we call move and rotate, the two functions move and move forward 200 and turn right 90 are called in sequence. In this example, it may not feel super useful. Here's a more useful and realistic one function to draw any square. The function names use parameters, which we'll explore in the next lesson. Drag the slider. Okay, wow. Hey, wait, okay. So, function takes parameter or value passed as a variable or argument. Value as argument as value, argument as anyway, draw square, cool, yep. But so this value I'm changing here, that would be said volatile or a non-static, as a matter of fact, runtime, given at a runtime. But so it's been stored in variable size passed by this control in the user interface and used in each function call moving forward, to move forward the same amount that's stored in size variable, while the angle degrees are hard-coded static values, fixed. How to define my own functions. Let's break down how you define a function. Function definition starts with the function keyword followed by a space, the function's name, parentheses, and a colon. A space, name, colon. The instructions inside the function must all start with a leading tab. So leading tab. You can insert that tab character by pressing the tab key. We call those leading tabs indents. They're important. The computer uses them to know which instructions pull. So the last, anything after this set of instructions, starting from the first character place in the final row, would be outside the scope of function. Why do we use functions? You use code multiple times, run multiple instructions in one go, to put a name on multiple lines of code. Yeah, that's all true. Names in code have a rule. Function identifiers cannot contain spaces. In general, names in programming languages cannot contain spaces. The computer uses spaces to detect the separation between different keywords and identifiers. Instead of spaces, in Godot we use underscore. There's another convention programmers use in some other programming languages. Instead of using underscores, they start words with the capital letters. Except for the first one, with that convention you'd write function names like move forward or move local. Identifiers also have to start with a letter or an underscore. You can't begin with a number, but you can use numbers after the first character. Okay, gotcha. Which of the followings valid? Select all that apply. Valid, 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 valid. Moving the turtle to a different position. Draw 3 lines. Jump. Oh. In order to draw multiple squares in different positions, we introduce a new function for our turtle to use. The jump function picks up the turtle and places it in relative to where it is. So calling jump moves the turtle 100 degrees left and 50 degrees down, pixels down, pixels, not degrees, without drawing any line. Draw 3 lines, 1, 2, 3. So what? So what? Until now you had to write code by hand and it's boring. It's time to code reusable functions. You'll use it to draw multiple squares. Second practice is multiple squares. Now you created a function to draw squares. You can reuse it by calling it multiple times. Okay. Code a function named draw square. Draw square. Move forward. Move, turn. Right. Code a function named draw square to draw one square of length 200 pixels. The function should take no parameters. I use move forward and turn right functions to instruct the turtle. In following practice, I'll use the draw square function to draw multiple squares by calling your own function. Okay, so since it is a square and turning right, hint function to draw squares, code function named draw square. Okay. No, okay, gotcha. Yeah. Again. Cheating. 1, 2, 3, 4. Okay. So there's the code as expected. And drawing multiple. I have a function to draw one square. I've already created draw square for you. Create a function named draw 3 squares that calls draw square 3 times. Okay. So function draw 3 squares. Draw square. So if I just call it 3 times, it will draw over itself. So jump call the jump 3 by 3, 3 by 300. Jump 300, 300, cheat, copy. Well, oh, pardon. Yeah. Jump. 1, 2, 3. Okay. My first function parameter. In the previous part, I created a function to draw a square of fixed size. This function is a bit limiting. Instead, it would be much better if we had a function to draw a square of any size, or better, any kind of rectangle. A square is a specific kind of rectangle. In previous lessons, you used the rotate function and gave it an argument. Just like a rotate. We can also give our function parameters. Parameters are labels you give to values passed to the function. Can I rotate in both directions? Okay, positive, negative, left, clockwise, counterclockwise. Gotcha. Function rotate in radians. And function rotate in radians wherever, when you call rotate 0.5, the computer binds the value 0.5 to the label radians. Whenever the computer sees the identifier radians inside the function, it replaces it with the 0.5 value. The parameter name is always a label you use to refer to a value. The value in question can be a number, text, or anything else. For now, we'll stick to numbers as we have yet to see other value types. Other value types. What is a function parameter? A number used to make calculation, the name of function, a label I give to a value that the function receives passed by. How to create functions with parameters. You can give your function parameters when writing its definition, the line starting with the function keyword. To do so, you add the name inside the parentheses, length. You can give parameters any name. How you name functions and parameters is up to you. Just remember, these names cannot contain spaces. To write parameter names with multiple words, use underscores. The following function definition is exactly equivalent to the previous one. Okay, we've seen this. Point. Okay, what's correct syntax for a function definition? This is correct. Oh, pardon, this is the one. Yeah. Don't do it. Functions can have multiple parameters. Parameter 1, parameter 2. Oh, that's why the space is after the comma. Must I write space? I must have space between function keyword, but however, because we use comma to separate parameters, it doesn't matter if you use spaces between, as long as you have the comma, either syntax is correct. Okay, then no. The following example defines function that uses two parameters to move an entity on both the x and y axis. Offset y and xy. Parameters are optional, dude bro. What's the correct syntax to define a function with multiple parameters? Function name, oh no, function name, parameter, 1, 2, function, okay, second one. Drawing corners of different sizes using function parameters, code a function you can reuse to draw corners with lines of varying sizes. Cool. So before we created a rectangle of any size, let's first see how we can use parameters to draw simpler shapes. Here we have an incomplete function that will draw corners with lines of any length, but it's missing its length parameters. Okay. The function will move the turtle forward an amount defined by the parameter length, turn 90 degrees, then move forward length pixels. Okay. Are we cool now? We cool? The function will move turtle forward and amount defined parameter length. Complete the draw corner function so it uses length power to draw corners. Okay. Okie dokie. Move forward length, turn right, move forward length. Why did he do 2 times? Why draw corner 2 times? Who called the draw corner 2 times? Who did that? Is it God? In this practice, we'll improve our draw corner functions so the angle can also vary. Add the angle parameter after the length parameter function and use it to draw corners of varying angles. Angle. Now I'm copying pasting because I'm certain when this is a variable function parameter and a variable that has to be the same for the use case throughout this scope of this code block, meaning pass the value. Is this passing value by reference? Is angle a reference? So I'm not passing any value. The demo is doing that for us. This is still very basic for me, but I like it going through these exercises to solidify the perception of the code syntax rules, because I'm very used to curly braces. This code block indentation is still, I mean, I'm used to it already, but it's weird. For somebody who is used to curly braces, this can lead to, this can produce a lot of errors until getting used to. we want a function to draw squares of any size, we could use these squares as outlines when selecting units in a tactical game as a frame for items in an inventory and more. Create function named draw square that takes a parameter the length of the square size. Okay, so this is nice. So I can just type and know what I'm doing. That's important. So there are many exercises, many of these courses exercising the skill using function definitions, declarations. What does it say? Create a function. Creating functions, because scripting is actually also a form of functional programming. Create a function named draw square. Draw square. Length. Okay, I need to have this in mind. Okay, turn right. So there is a framework that provides, in the background for these courses, there is a framework that provides functions, implementations, turn right, and parameter. So I'm also supposed to implement program move, then forward right, by length, by length. And as I'm drawing a rectangle, three, four. Drawing rectangles of any size. Let's make our square drawing function more flexible to include rectangles of varying sizes. My job is to code a function named draw rectangle that takes two parameters, the length and the height. Okay, so it's not squares, it's length, height. So I guess this should be it, and then length, height. Do it. Yep. He did it. Introduction to member variables. In this lesson we take a first look at variables. In games you need to keep track of many values that change over time. So, not just games. All programming is actually choreography, counting, constantly counting things, keeping a track, all ups. Player score, every character or enemy is held, the last checkpoint, and so much more. You need to store, retrieve and update those values. We call those values variables. Variables are labels used to keep track of values that vary over time. Here is an example of variable tracking. A character or monster is held. No, var held equal 100. The line above defines a new variable name held and assigns it to start. Okay, that's equal sign does. More on that below. Function parameters, which you saw in previous lessons, are another example of variables. Yeah. Pass value by variable. In this lesson we start using variables built into Godot. They are a particular kind called member variables. Built in. In this lesson we start using variables built into Godot. They are particular kind called member variables. Member variables are values attached to a game entity. Their useful properties like the position, rotation and scale of a character. In previous lesson we saw how one, rotate, reset. This function increases or decreases the value of the entity's rotation member. Okay, rotation members variable. This function increases or decreases the value. Say we want to reset the rotation to 0 and make the character. Oh, so this is a member variable. But the function called rotate is a setter function. To set the member variable. Because we have rotation 0, run 0. Say we want to reset using rotate. So there is a difference here. This function passes the value to the rotation, which is the member variable. So entity, this function decreases the value of entity's rotation. So rotation is the member variable, which is this one. Here it's defined this way, directly, direct assignment, value assignment, or imperative, or direct. And this would be assignment by passing value. With setter function, I guess, let's say. Notice how we use the equal sign to change value of the value of a variable function that varies over 10 decimal. A label, okay. Accessing sub-variables with the dot. In video games you'll see many member variables that have some sub-values. For example, the position has two coordinates, x and y. Is the same for scale, it has x and y sub-variables. They respectively control the horizontal and vertical size of game entity. To access those x and y sub-components, you add a dot after variable name. The code below places the entity 200 pixels on the x-axis and 250 pixels on the y-axis. Position dot x sub member or the member of the position class. Class member. Member variable. Okay. Notice how we use the equal sign. Yeah. Cool. Unlike in maths, in computer programming, the equal sign equal doesn't mean is equal to its assignment. Yeah, the assignment say it assign. The result of the expression on the right to the variable on the left. We assign values so often in code that we prefer to reserve the equal sign for that. We assign values so often in code that we prefer to reserve the equal sign for it. In games, the y-axis is positive going down. Just like in CSS and anything on computer, the coordinate system on the display starts from the top left corner. Like reading left to right. So less transformations, less coordinate translations required when dealing with text or other visual elements, symbols. Note that in game, assuming your character position starts at O, the code above moves the entity 200 pixels to right and 200 pixels down. In the mod, the y-axis is generally positive going by. Okay. Grip script divider, point downwards. Going direction on computer happens to top left. Yeah, that's what I said. And scaling, okay, scaling, go big. No, can't go bigger. How do you access sub-variables? Dot, right dot, go. In a future lesson, we'll explain how and why and how those variables have sub-variables. For now, just know you can use the dot to access them. We'll tell you which variables have subcomponents and what their names are. In the next lessons, you'll create your own variables and do operations on them to add or remove score, health, you name it. For now, let's practice assigning variables. Draw a rectangle at precise position using the position member variable and its sub-variables to change the rectangular value. Draw a rectangle of 200 by 120 at the x position of 100 and y position of 100. You need to replace the numbers in the code editor to draw correct rectangle. So add position and draw takes height and length. Position 100, 20, 100 and 200, 120. Go. We did it. Draw squares at different positions. Draw 3 squares of size 100 by 100 that are 100 pixels apart on the horizontal axis. In other words, there should be a 1 pixel gap between 2 squares. You should draw the square starting at the position 100. This means you should position the first square at 100. Remember, you need to use the equal sign to change the value. Like turtle's position. Write your code inside the run function so the computer can recognize it. position, draw position, draw 3 squares of sides 100 that are 100 pixels apart. Starting at position, okay. So let's say I'm naive, so I just imitate the previous example. Position dot x equal 100 copy paste position y 100 and I say draw what square? Rectangle. Three of these. Okay, so I call this 3 times. But 200, 300. Draw 3 squares of size. Oh, excusez-moi. Excusez-moi. Can I expand on that? Length equal 100. Height equal 100. Can we expand on this like this? Can we do that? Is this too much at this point? Too far? You can't skip не. I know it. Let's go. Oh, so 100 and 100. Oh, it's a 200. Okay. Sorry. 3 5. Is this math exam? Or what? What should actually be happening is store each rectangle created, have them stored, let's say, in an array, and take from array, iterate through it, grab the array element containing specific rectangle, and taking his members, so we don't need to hard code values. That would be advanced, enter-level advanced coding, or intermediate. advanced counting, since programming is counting choreography, choreographing counting. That's all what coding is, defining your own variables. 2 hours in the stream, hitting stream marker, going to the short break, because that's how we brawl here, bro. I know you like these, eh? Hey, yeah. Where's this big be right back? Go away. I'm back. So, like I mentioned previously, I'm going through this like a entry-level basic introduction to GD script, because it's necessary to take this course, and I try to explain what is the aim that I want to train my brain to use this as a second language, to start describing, so I can translate my vision of a project I want to create. And there is a second notion to that, because when I learn to code, I'll be able actually to more efficiently create a game design or design a game and create sections, parts, chapters, ideas, and I will know how to script that vision. The story mode, the scenes, and that's a big help. Learning all these basics facilitates ability to create a design document. It's okay to have human language descriptive, I don't know, game design, but it should be close to the selected preferred framework that will be used for development of the project. So when I learned this, I'm halfway done with game design. I can say it that way, put it that way. I'll have this running session and close it at on 3 hours, but I'll revisit it probably just again same day today, at least where I am, which is GMT +1, Northern Central Mediterranean, Dalmatia, and we need to go this screen and get the show soundtrack going. So it's even possible when one gets very familiar with one programming language, it's possible to prototype everything in a code without the detailed specific implementation. Even with just defining in the source code general of creating functions and defining the structure is a big work. Then it's when those spots, placeholders are defined in the source code, it's easier to use a source code as a documentation, a roadmap for development, and a dev log and to-do list. And it's even good to have, for one, to have a conversation with itself in a code, comment sections of the code that describe the following code block. Comments in the code are actually good starting point to realize the task one wants to, what the following code is, what before the code is created, how to define it. Sometimes I would start in a row, like draft up a code sequence and put it in the comments, and then copy paste it, uncomment parts, so I can track the original idea, what parts are missing and what's implemented so far. And then as the comment section describes the following code implementation, It also keeps the references in a readable human form. What the poet meant to say, what the writer meant to say with this. So, defining our own variables. In the previous lesson, you used the predefined member variable name position. Yeah, true. In our projects, we'll need to define our own variables. Imagine that you need to track the player health in your game. One of the closest things I could compare this to with member variables properties could be maybe like using jQuery, which is a, let's say, user interface JavaScript framework for web pages to create user interface. And they provide predefined functions, members, properties for user interface elements. So it's possible to animate them, put style, create styles, interactions, animate the user interactions. The jQuery is more powerful than just doing a makeover for a web page, but it's designed with the task at hand. What one wants to accomplish with visual. Back to topic here. In our projects, we'll need to define our own variables. Imagine that we need to track players' health. Cool, they may start with 5 to 4, hit 3. Keep track of that. Create a variable named health to which you add subtract. Example below introduces the print, which outputs its argument to the output box on the left. Click run button to instantly run the entire function. Click step button to exit the lines of code one by one. The debugger panel at the bottom shows the current value of the health variable. Run. Health 4. Variable health equal 5, health equal health minus 1, print health, okay. Step. Health 5. Health 4. Below we'll break down how you define your variables and explain the print function defining a variable. Can you read this? Well, not if you're on mobile, you can't. I was just about to remove the effect from my camera. So we need to define the variable for computer to register it. It's in other words, it reserves memory and has a memory space in a dynamic environment and keeps a reference to that memory block. Whether something stored there, changed there, and whatever. That's something like taken from C++ or C. To do so, you'll start a line of code with the var keyword followed by the desired variable, like function states for variable states for variable. Variables are case sensitive, which means health and health are technically different variables. Be careful to use the same capitalization wherever you refer to the same variable, or you could be reading or writing to a different variable. The following line defines health, pointing to no value. You can think of it as creating a product label. You have yet to stick onto something. Like with functions, a member variable's name must be unique inside a given code file. Like with functions, member variables must be unique inside a given code file. A member variable's name must be unique. So is the file, script file, a scope? Creating two variables next to each other with same name that cause an error. Okay. To use a variable, you want to assign it to a starting value. You can do so using the equal sign equal. Okay. This code assigns value 100 to a new variable named health. Output run. Health, print health. Number health. Well, notice we don't use the verb anymore, as we only need to define needed variable. Keyword is only to introduce new variable when it's defined first time, and that's it. So equal sign is further in the code used to equal sign is used for value assignment. Run step. Okay, so print works with the output. The debugger shows the state. About the print function. The print function is generally the first function you learn in academic programming courses. It sends print the message or value you give it to some out window, often a black window with a plain text. Programmers often use print to quickly check the variables of their value of their variables when their game runs. In the app we made a special output window that captures calls to print and displays a card to make it friendlier for you. Print. Hello there. Here the word print means to send information to display on screen. The function prints things on your computer display. It doesn't relate to printers. Variables are like labels. We've hinted above. GDScript variables work a bit like labels. Assigning a value to a variable is like talking to your label variable and sticking it to some item, the value. Like a supermarket has a database of products, the computer keeps a list of all variables in your code. Given the variable name, the computer can look up the attached value. It has an important consequence. In GDScript, you can stick that label to any other value. Health text. This is some text. Step run. Step 2 variable health equal 100. And now health turns into completely different type, which is text or string. The above code is like taking a label from the appropriate item, sticking it to the wrong thing. At line 2, the health variable holds a number type, or the type of our numbers. From line 2, 3 holds the text. The computer will let you do that. The code syntax and the grammar are correct, but it's not good. Yeah. Variable names should describe the value they contain, so a health variable with a text file will confuse your future self and other coders. It can also cause errors in your game. Later on, we'll see how to avoid this issue with variable types. For now, let's practice creating variables. Oh my, practice. define. In this practice, you'll define your first variable and give it a specific starting value. Okay. Define a variable named health with a starting value of 100. Var health equal 100. Wow. There's no stopping me. What's Dora? What's who? Dora who? I did it. It does it. It does it. It does it. It does it. Adding and subtracting or correcting in our game will have health by defining the health variable, the blah blah. Health changes adds tension to the game, especially if the player is fighting with low health. It's a resource that players should manage carefully. Characters' health might get low if an enemy attacks or they fall into a hole. You can create a function to represent damage in these cases. Take damage amount health minus equal amount. We pass the amount of damage the robot should take as a parameter. Take damage 25. Ouch! Line 2 subtracts amount from health. Note the syntax. C plus minus equal. It's a shorthand we often use. You can also use longer form. Both of these lines have the same effect. Health minus equal amount or health equal health minus amount. There you go. Got that? You may notice that the health of the robot can go below 0. Oh. Take more damage, you robot. Super die. No. There's no death implementation here. We'll see how to manage this in future lesson using conditions. The robot's health could increase instead if the player picks up an item that heals them, or if they use a healing item. Here again the health can go beyond 100. Heal plus equal. Heal. Yep. Also, once more, the short line health plus equal amount is equivalent to the longer health equal health plus amount. Which of these would increase the health of robot? Select all if apply. Increase. Plus, let's like this. Yeah, got your ass. Oh, go. Damaging the robot. Learn how to deal damage to entities like a roboto. Damage. Okay, health minus equal amount. You're dead. Robot's dead. Dead robot. It's time to heal the robot up to full health. Write a function called heal that takes amount as parameter. Function heal amount and health plus equal amount. The robot starts with 50 health and will heal 50. Who will give it 50? Yippee! As we've seen, Godot has a function that does certain actions. For example, the show and hide functions change the visibility of things. We can also create our own functions to make custom effects like adding or removing health to a character. Godot also has special functions we can customize or add to. Take the process function, delta rotation 0.05. Okay, the process function gets its name because it does calculations or continuous actions. It's like a juice factory that processes juice bottles. The bottles are always moving along a conveyor belt while different machines operate on them. It's similar in Godot, but this function can run hundreds of times a second. How many parameters does this one take? One. Delta. What about the delta? The process function won't do anything until we add something to it. You might notice the underscore in front of the this is important. This is a convention programmers use to coordinate work, and it will only make sense once you have experience coding in Godot. For now, all you need to know is that if the function exists in your code and it is called precisely process, the Godot will automatically run it every frame. When Godot draws on screen, we call that a frame. Is this the same for other engines? Other engines might use different names like update. Why is the process function useful? It's perhaps better to see the process function in action. Take the following example. Rotate 0.05. Set process true. What? Okay, stop it. When you click button, you activate processing on the robot. From there, every frame Godot runs the process function. Since we wrote a rotate instructions, Godot is rotate. Okay, get it. Multiple times a second. In practice, you'll learn how to use process function to rotate and move character yourself. Rotate a character continuously. Make the robot rotate slowly by adding to the process function rotate speed of about each frame you should do. Is it rotate delta or rotate 0.05? Are we doing this? Make the robot move in a large circle slowly by rotating it and simultaneously moving it along its x direction. To do this, add the rotate and move local x functions to process. Rotation speed 05 radians per frame and move the robot 5 pixels per frame. Rotate 0.05. Move local. Move local. X 5. Character is moving in a circle clockwise. Why would it move in a circle? Okay, I rotate it and move it. Hint 1. If I move it x-axis, why would he move in a circle? Where's the center of rotation defined? This is bad. This is not good. Move local file, rotate. Comment the rotate, and he goes off. He went there. So that's linearly moving along x-axis positive. And what's changing where's the change of, so move local is a well, simple stupid example, but I don't agree with it. We've seen how we can use our character process function to make it move continuously, rotate delta, but it's not just our character that has a process function. Almost everything in the game has a process function. Dozens of times per second, Godot runs every process function in the game to update the game world. After that, it displays an image of the game world on the screen. We call that image a frame. Godot then moves on to calculating the next frame. As this happens dozens of times per second, you get the illusion of movement. This is similar to how traditional animations work. This sounds like frames per second. You may have heard of frames per second. Game will run at 60 FPS. It means that everything updates each second. The number of you may get frames at hundreds of times frames. Okay, let's look at the process function in more detail. What parameter does the process function take? Delta. Frames take varying amounts of time to calculate. Depending on the game, the computer, and what the game engine needs to calculate, frames take more or less time to display. There will always be a milliseconds variations from frame to frame. That is why the process function receives a delta parameter. Delta represents a time difference. It's the time passed since the previous frame in seconds. We can use it to ensure that the changes between frames don't make the game's behavior unreliable. So at the end of the last frame, the delta is updated, I'm guessing. So when I get it when it's passed in the function process, it's possible to timestamp the execution instructions in the given function and make sure. So one is, it helps one implementations for the performance. Delta represents the time difference. It's time passed since the previous frame. We can use it to ensure that changes between, okay, this is because different computers run differently, so a fast computer will have more frames per second than a slow computer. If we ignore delta, the game experience will vary depending on the computer. Delta helps to make the game experience consistent for everyone. What do we know about delta? I guess it's all of these. Multiplying by delta. The delta you get in process is a time difference in seconds. It will generally be a tiny decimal number. To apply delta, you need to multiply your speed values by it. When multiplying by delta, you make motion time dependent rather than frame dependent. Okay. Why do we use the number 3.0 in this example? At the top of the lesson, we made the robot rotate a fixed amount every frame, 0.05 radians. In the example above, we now multiply the argument by very small delta value may... okay. So if it's a fraction of a second, the given fixed 3 radians will also turn out to be a fraction. However, multiplying by a number below 1 like delta makes the result smaller. To compensate for that and make the robot turn fast enough, we use a large number like before instead of 0.05. Those numbers have two different units. 0.05 is an angle in radians, while 3.0 is angular speed in radians per second. To compensate, we use larger number. When you multiply a speed by a time delta, it gives you an angle. Don't worry if it is a little confusing for now. Okay, so rotate will always get a value. It's not asserted expression. There's no assertment for this expression that will be valid value. But works for this example because this result will always be in the scope of value type for radians of a radians type value. Why the time between frames matters? The time it takes to display a new frame varies. If you don't take that time into account in your code, your game will have gameplay issues and bugs. Godot provides that time to the process function through the delta parameter. In the example below, the top robot moves using delta. As a result, it moves at a fixed speed. The bottom robot moves over a constant distance every frame. Without taking delta into account, it will move faster or slower than the top robot on your computer. The bottom robot will move differently for everyone. With delta. Constant. Multiplying time sensitive values by delta makes them time dependent rather than frame dependent. Thanks to that, we get reliable movement over time. That sorts the whole issue about performance optimization right there. Without delta, frame times vary from computer to computer, and during gameplay, because of that, the movement will differ for every player, making the game inconsistent and messy. What does this mean? Rotation times delta. We are subtracting now, we are multiplying rotation speed by delta. Rotating using delta, moving a circle using delta. Okay, this is good practice also. 45 minutes in. At the moment, the rotation robot is frame dependent. Add delta to make the rotation speed time dependent. The robot should rotate 2 radians per second. 2 radians per second. Well, Gotcha. In this practice, make the robot move in a smooth circle using delta. To get this movement, the robot should rotate 2 radians per second and move 100 pixels per second towards clockwise. Please write the values in the parentheses when calling the function. If you define extra variables, we will not be able to check your practice. What? It was then move. What was the function? Move local x. Delta. Scale what? Move local scale what? Okay, I think I got it. So rotate 2 times delta and move local, load cell, was it x? 100 times delta. Running test. Yep. Well, who'd say, huh? Using variables to make code easier to read. In this lesson, we'll make our code easier to follow and understand at a glance. Take a look at this example. In the above example, what does the number 4 mean? Okay, it's how fast. We can guess that number represents by looking at the function name, but it's harder to recall what this number does by quickly looking at the code. We've seen how different functions have their own names. Using these names communicates to the developer what the functions do. Rotate 2 radian. In this code example, horizontal, move local x, move local y. As we learned in lesson 8, we can also assign labels to numbers to help us remember what they do. We call these labels variables. A variable is a label for a value we can save, change and read later. Let's recapitulate how to define a variable. Keyword var, variable name, space equal value, space equal space value. Okay, we improved the first example to make it clear with the number, what the number 4 does. Variable is angular speed equal 4 process delta rotate angular speed times delta. There you go, clear. In the above example, which line defines the angular speed variable? If we define variables outside of functions, we can reuse them in different functions. If we define variables outside functions, we can reuse them. Okay. Because any function can use variables we define outside of them, we call these variables script-wide. So that's the scope definition. Scope in a sense, where is the given variable name readable, accessible, approachable. If we define variables outside different parts, because we call this script wide, here we use the angular speed script wide variable in both process function and the set angular speed function. Angular speed equal 4, definition, function delta angular speed call, passed by passing to rotate function, actually doing calculation in the function call. And there is a setter function angular speed, new angular speed equal new angular speed. We call this, we can also define variables inside of functions. We align the variable assignment by indenting to make it a part of a function body. Make sure to create the variable before using it. If we define a variable inside of a function, only that function can use it inside. So block scope, value access, variable access. If we define, okay, so process delta, assign, create assign, calculate expression, set new error, no defined label. The angular speed variable only exists inside process because we define it there. The set angular speed function can't use it. Trying to use it there will result in error. Here's what this error might look like. The identifier angular speed isn't declared in the current scope. Where can we define variables? Inside functions, outside functions, submit it. Variables are also great at grouping values that control how a character behaves. Variables are also great at grouping values that control how a character behaves. Well, that in this example of code, in this code snippet, what is handy here is the fact that they are written in the source code together on the same place and create a they just visually create a structure, but there is no logical structure around them like a class or a function. They are just a combination with the comment, text in the comment next to them, and just another group. But they are not logically grouped, functionally grouped, or relevant to runtime and during development, only if one goes manually read over there. In the following practices, we'll define variables and use them with some familiar functions to make our code more readable. Verifying code using variables. Using variables to store numbers, values makes code easier to read. Tidy up this function box, store a value in a variable. Let's give the for here a label so we know what it does. Okay, outside the function, variable angular speed and assign for. I can just copy this, paste, damn it, I'm good. Fixing an out of scope error. There's something wrong with the code here. Can you see what it is? Run the code and read the error. Correct the code so it works as intended. I know. Line 6:1, line 6:1. Well. Guess what? And there we go, fixed. Come on. Bloop, 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 bloop. Bum, 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 ba-dum. Conditions, 2:56, so I'll wrap it up. 3-hour stream here, long session, but shorter than day at school, having the same subject for a whole day. Could be too much, but I still want to go as soon as possible through this. It's very readable, very easy to follow, and it asserts knowledge taken, especially the syntax and the writing rules. Indentation is constantly here being used in examples. Conditions. Okay, so lesson 13. Do I have a save? Lower contrast, sample text? No. I'm expecting this app to break for me. If I close this, it will not. I don't know if does it use cookies, so it will remember my browser when I reopen it for the next section. So how would I do a recapitulation of this stream? Well, it's boring, but someone's got to do it. What's this sign? Report issue? No, okay. Well, if I try to do recapitulation, I could just say for recapitulation about this. So I've jumped into for day 5, learning Godot, game development in Godot, more specifically on the topic subject GD script, Godot script. There is a learning app. One can get it from I think introduction here, learning to code with GD script, and if I click here, there should be a link, learn to code in introduction, getting started. Click here to access this app, learning from zero. So in 3 hours I have a background knowledge, so it's clear for me, but this is the first time I'm facing this type of syntax with code block indentations or function definitions. I'm very used to curly braces. And I went through basics with examples that are like interactive examples, and I'm at the 13 conditions. What is this chapter? Lesson 13. What's been covered from beginning towards here? There are functions are introduced and variables, and the member function for every entity in the game engine, which is process and process delta, which actually provides a mean to optimize performance, make it seamless on every type of hardware. Process delta process function underscore process refers to inbuilt function that actually it's repeated every frame. It's involved in rendering and updating the image of the frame, while delta passed as an argument in that function is a time difference between frames. So it's a variable value. Value can vary. It's derived from performance from frame to frame as the process. As engine processes calculates each image of a frame, the delta is a given also as a result. It's like it's not constant, it's the inbuilt, I'm guessing so far, it's inbuilt variable that holds and allows using the time in milliseconds. Well, anyway, time difference in seconds between frames drawn. Outro. Does it matter? Outro. Yeah, it matters. Make it official. Keep it tidy. I'd like to get back in an hour and continue. That would be day 5 part 2. And do I have the outro? Yeah, there it is. Thanks for stopping by. Thanks for new sub on Kick. Well, Trovo is on work days. It gets really quiet. See you soon.